The video opens on a home movie from the late 1990s. A 2-year-old, in an oversized paper crown, is staring down a cake. Adults chant a shaky version of Happy Birthday. Someone nudges the toddler's hand toward the candles. Tiny cheeks puff. Wax bends. Everyone cheers. Cut to that same person now in their 20s, watching the footage on a laptop. They laugh, but then their face changes. Because as familiar as the scene feels, there's nothing behind it. No smell of frosting, no sense of the room, just video. The memory isn't really theirs at all. This happens to almost everybody. Parents swear you loved dinosaurs at 18 months. Photos show you at the beach at 2. Yet when you close your eyes, darkness. Psychologists have a name for this strange blackout: childhood amnesia. You'd think that with billions of neurons and years of life, the brain would hang on to something. Anything. But doesn't. Not most. Almost none. And that vanishing act has been puzzling scientists for more than a century. Why does the story of your life start halfway through the first chapter? Is it because babies don't form memories, or because later you erase them? The answer turns out to be weirder than either option. As we rewind human memory back toward the cradle, we'll need to look at rats in mazes, 19th century diary keepers, and even the evolution of language itself. But first, we have to pin down what exactly counts as a memory. Before we can explain why early memories disappear, we need to ask a basic question. What kind of memory are we even talking about? Psychologists divide memory into several systems. There's procedural memory, the know-how that lets you walk, chew, or later ride a bike without thinking. There's semantic memory, the abstract facts you learn, like that Paris is the capital of France. And then there's episodic memory, the ability to mentally time travel back into a specific moment, with a sense that it happened to you. Childhood amnesia is mainly about episodic memory, the kind that lets you say, I remember my first day of school, and actually relive it. Here's the catch. Infants clearly learn. Newborns recognize their mother's voice and smell within days. At 6 months, babies can distinguish faces they see regularly. Experiments show that even tiny infants can remember a pattern of sounds or a mobile above their crib for days or weeks. So the brain is recording information from the very start. What seems to be missing is the later ability to pull those early episodes back into awareness. That distinction is crucial, because it suggests the problem isn't a blank beginning, but a shift in how memories are stored and retrieved over time. To see how we discovered that, we have to go back to some of the first people who tried to measure childhood memory scientifically. In the late 1800s, psychologists armed with notebooks and a lot of patience began to track how memory appears in children. One pioneer, the German psychologist Hermann Ebbinghaus, was already famous for testing his own memory with nonsense syllables to map forgetting over time. But it was his intellectual descendants who turned to childhood. In 1895, the American psychologist Caroline Miles used a simple tool: detailed diaries. Parents wrote down everyday events in their toddlers' lives. Years later, those same children, now school-aged, were asked what they remembered. The results were unsettling. Even dramatic episodes, like a broken arm or a house fire at age 2, were usually gone. Through the early 20th century, researchers like Sigmund Freud and Henri Wallin discussed the absence of early memories, each offering very different explanations. Freud famously suggested that the mind represses early experiences, especially emotional or sexual ones. It made an intuitive story. But as data gathered, repression began to look less convincing. By the mid-1900s, surveys of thousands of adults converged. Most people's earliest clear autobiographical memories clustered between ages 3 and 4. Some reached back to 2.5, but almost none reliably earlier. If repression wasn't doing the erasing, what was? To answer that, scientists turned from diaries to the actual machinery of memory inside the brain. If you could point to one brain structure most responsible for episodic memory, you'd land on the hippocampus. It's a pair of curved structures buried deep in the temporal lobes, named after the seahorse they vaguely resemble. Damage to the hippocampus in adults famously produces profound difficulty forming new memories. In infants, though, the hippocampus is a construction site. Brain imaging shows that while the basic structure is present at birth, it undergoes intense growth and wiring during the first 3 years. New neurons are being born. Connections are being pruned and strengthened. Chemical signaling systems, like the balance of glutamate and GABA, are shifting roles. Animal research helped make this concrete. Studies on rat pups show that their hippocampal circuits can support simple learning very early on, but the kind of flexible, detailed mapping needed for episodic memory appears much later. Similar work in non-human primates suggests a slow ramp-up rather than an on-off switch. This matters because memories are patterns of connections. If the underlying circuitry is still being rewired at high speed, yesterday's carefully stored pattern may be overwritten by today's changes. So one part of childhood amnesia is structural. The hard drive itself is still being formatted. But structural growth is only half the story. At the same time, the infant brain is doing something that, for memory, is both powerful and dangerous. For a long time, neuroscientists thought that adult brains didn't grow new neurons. Then, in the late 20th century, work in songbirds and rodents showed that in certain regions, especially the hippocampus, new neurons keep arriving even after birth. In babies and young children, this process, called neurogenesis, runs at a much higher rate than in adults. At first glance, more neurons sound like a recipe for better memory. But here's the irony of development. The very thing that helps the brain learn fast may also wipe away its earliest records. Experiments in mice have been especially revealing. When researchers artificially increased hippocampal neurogenesis in adult mice, the animals became better at learning new tasks, but worse at remembering older ones. When they reduced neurogenesis in young mice, early memories lasted longer than usual. Picture what this means in practice. A toddler's hippocampus is brimming with newborn cells trying to integrate into existing circuits. To fit in, those cells reshape the network's wiring. Old memory traces are disturbed, like footprints on a beach when new waves roll in. On an evolutionary scale, this trade-off makes sense. Young animals need to adapt quickly to a changing world, not preserve every detail of their first months. Flexibility beats archival accuracy. Still, biology isn't the whole picture, because even as early memory traces are being remodeled, the way we encode and retrieve experiences is shifting with something uniquely human. If episodic memory is mental time travel, language is the passport that proves it was really you. Around their first birthday, many children begin to say recognizable words. By age 2, simple sentences appear, and by 3 or 4, vocabulary often explodes to hundreds or even thousands of words. Why does this matter for memory? Because to later recall an event, you need more than raw sensory impressions. You need a way to organize and label them. Studies comparing children from different language backgrounds show that as kids acquire more complex grammar and narrative skills, their earliest retrievable memories shift later. For example, English-speaking children, whose language encourages frequent use of I and explicit time markers like yesterday, often report slightly earlier first memories than children whose languages focus less on the self in conversation. Parents also play a role. Some caregivers use an elaborative style, asking kids rich questions about past events. Remember when we went to the park and the dog stole your sandwich? Others stick to yes-no prompts. Children whose parents consistently build detailed narratives with them tend to form earlier, more vivid autobiographical memories. This suggests that before you have a stable sense of self in time and the words to describe experiences, early episodes simply don't get translated into the kind of stories your adult mind can access. But culture isn't only about language in the narrow sense. Different societies emphasize childhood and the self in very different ways. When researchers ask people in different countries about their earliest memories, the answers don't all cluster at the same age. In many Western, individualistic societies, average first memories often fall around 3.5 years. In several East Asian cultures, including China and Japan, the average can be closer to 4. What's going on? One big factor appears to be how much families talk about the child as an individual protagonist. In New Zealand, a team working with Maori communities found something striking. Maori adults often recall events from significantly earlier in life than New Zealanders of European descent, sometimes as early as 2.5. One reason may be that Maori families place strong emphasis on genealogies and personal histories, weaving children into stories of ancestors and places from a very young age. Meanwhile, in some cultures that stress social harmony over individual expression, conversations about the past may focus more on shared routines than on unique one-time adventures. That can shape what sticks as mine. These cross-cultural patterns challenge a hidden assumption that childhood amnesia has a single, fixed cutoff. Instead, there seems to be a biological window within which culture nudges the boundary forward or backward. Still, even in the most narrative-rich families, there's a wall. Almost nobody, anywhere, has a reliable episodic memory of being a newborn. Which raises a deeper question. How do we know which early memories are real in the first place? Ask a room full of adults if they remember something from before age 2, and many hands will go up. First snowfalls, hospital visits, a loud argument. Some people feel certain. But certainty isn't proof. Memory is reconstructive. Each time you recall an event, your brain rebuilds it from scattered traces, sights, sounds, stories you've heard, photos you've seen. Over time, patches from other sources can be stitched in without you noticing. Researchers have tested this by giving adults lists of common early childhood events. Some really happened, confirmed by parents. Others were invented, like being lost in a shopping mall. Over repeated interviews, a significant minority of participants came to remember the fake events in vivid detail, complete with emotions and sensory imagery. Something similar can happen with supposed baby memories. A parent might retell a dramatic story so often that you grow up with a mental movie of it. Eventually, you experience it as something you personally witnessed. Brain development backs this up. Neuroimaging suggests that brain networks supporting mature episodic memory don't fully resemble the adult pattern until the preschool years. That makes truly self-experienced memories from much earlier highly unlikely. This doesn't mean your feelings about those stories are false. It just means that what we call a memory can be part history, part myth. So if childhood amnesia is partly biology, partly language, and partly narrative reconstruction, is it unique to humans? Psychologists turn to animals to ask a blunt question. Is there such a thing as childhood amnesia in species without culture or language? Rodents, with their short lifespans and rapid development, became a key test case. In classic experiments, rat pups were exposed to a mild shock in a particular box. Tested shortly afterward, even very young rats showed fear responses, suggesting they had formed a memory of the context. But when these events happened very early in life, that memory faded unusually fast. Adult rats, in contrast, retained similar experiences much longer. When scientists manipulated the rat's brain development, for example, slowing down hippocampal neurogenesis, early memories became more persistent, echoing the mouse studies we met earlier. That pointed again toward brain maturation, rather than repression as the main driver. Non-human primates add another layer. Baby monkeys can learn to use tools or recognize specific humans, but how far back their episodic-like memories reach is harder to test. Still, patterns of forgetting in young animals across multiple species look broadly similar to our own. On an evolutionary timescale, this suggests that childhood amnesia isn't some quirky byproduct of human society. It may be a common feature of brains that trade stable early records for intense learning capacity. Which brings us back to that home movie toddler. If forgetting is built into our biology, what does that mean for who we think we are? Return, for a moment, to the person watching their second birthday video. The candles, the paper crown, the laughter, none of it available as a lived experience. Yet somehow, this unremembered day still shaped them. That's the strange lesson of childhood amnesia. Your conscious life story begins late, but your brain and body have been under construction, absorbing patterns since before birth. You don't recall learning to walk, but your gait still carries traces of that trial and error. You don't remember your caregivers' faces from those first months, yet your attachment style, your expectations of comfort or distance, were already being tuned. From an evolutionary perspective, this amnesia looks less like a glitch and more like a strategy. Human babies arrive unusually helpless compared to other primates. We have massive brains, but our skulls can't grow too big before birth without making childbirth impossible. So we finish wiring much of our neural circuitry outside the womb, in a world full of language, culture, and other people. In that noisy social environment, it may be more adaptive to keep circuits flexible than to protect pristine early episodes. Forgetting is the price we pay for being able to learn so much, so fast. Memory is not an archive, it's a tool. It also complicates the idea of a single, continuous self. We like to think of ourselves as the same person across time. Yet none of us can remember being the baby we once were. In a sense, each of us carries a stranger's history inside our skulls. And still, that history matters. Early stress, nutrition, caregiving styles, and even exposure to language leave molecular and structural marks throughout the brain. The person you are now is partly carved by events you will never consciously recall. So when we argue over what defines identity, genes, choices, culture, childhood amnesia quietly adds another layer, the invisible years. Which brings us back to you. When you watch your own baby photos or listen to family stories about your toddler mishaps, do you feel like you're meeting someone else or remembering yourself? Where do you draw the line between story and memory? Between who you were and who you are becoming? Let us know in the comments. What's the earliest event you're reasonably sure you truly remember? And how do you know it's real? And if you'd like to keep exploring how deep time and biology shape everyday human experience, a subscribe and a like genuinely help this channel reach more curious minds.